Nuclear energy. Isn't it wonderful? Harnessing the power of nuclear energy is probably one of the greatest feats of scientific research and engineering in recent history. We see its applications almost everywhere in medical and industrial fields, but the one we see most of is electricity generation. I'm here today in front of this power plant, the Salem Nuclear Power Plant in New Jersey, to discuss the long process of nuclear electricity generation, and it all starts with the element uranium. Now, uranium is highly radioactive and therefore produces an enormous amount of energy. Unfortunately, U-235, the kind we use in reactors like this one, only makes up about 1% of natural uranium. This uranium is mostly mined in Wyoming and the Four Corners region in the US, and once it's mined, it's processed into fuel rods for use in reactors. Now let's actually find out how these reactors use these fuel rods to help generate electricity. There are two processes by which this could all happen: the process of fission and the process of fusion. Fission is the process of splitting atoms apart, while fusion is bringing them together. We use fission in reactors because fusion is unreliable and unstable by current standards. Fission is what makes the heat, and the heat is what makes the magic happen. There are pressurized reactors making up about 2/3 of reactors. These reactors use the uranium fuel rods to heat up pressurized water in one chamber and then transfer the heated water to another chamber, where water boils and creates steam. This steam then spins a turbine, which creates electricity with the help of a generator. Boiling reactors make up the other 1/3 of reactors. The main difference with how these work is that the water is boiled in the first chamber and creates steam right away. However, with the way these are set up, the boiling water ends up contaminated and usually must be disposed of. And speaking of contamination, what exactly are the pros and the cons of using nuclear reactors? Now, if we look at the pros, there's a large energy output like we've said before. There's low greenhouse gas emissions, they're reliable, they stay on 24/7, they help the economy, they create jobs, advance technology, and even help a nation's development. However, don't get me wrong, there are some cons. There's nuclear meltdowns, some that sound horrible. It's a huge financial undertaking, and that's an understatement. Of course, there's nuclear waste and a limited supply of uranium that can't be replaced. However, some of these cons are up for debate. While nuclear meltdowns are a possibility, there are very few that are actually a reality. Most nuclear accidents aren't as severe as the ones you hear like Chernobyl or Fukushima. While nuclear plants do cost a considerable amount of money to build and decommission, they have extremely low running costs compared to the competition. Now, nuclear waste does present an environmental concern. However, there's actually much less nuclear waste than many people have learned. There are facilities meant for disposing low-level waste, and we have a permanent dumping site planned in pace. Recycling nuclear waste and repurposing can also be done. And while many countries do so, the US still has yet to be one. As for the limited supply of the uranium source, there is an estimated to be between 100 and 300 years worth of uranium, depending on the source. However, there are multiple ways to actually increase the supply and make it last longer. Not to forget, within the amount of time, technology will advance and more ways of mass energy production will be discovered. But that will have to wait to be uncovered. Thanks for watching.